1.2 Scalar and vector. Physical quantity can be divided by two quantity, scalar and vector. Scalar quantity is defined as quantity with magnitude only. Example: mass, distance, speed, work, pressure, current, temperature. Vector quantity. Vector quantity is defined as quantity with both magnitude and direction. Example: displacement, velocity, force, momentum, impulse, torque, electric field, magnetic field. Unit vector. A unit vector is a vector that has a magnitude of 1 with no unit. Its only purpose is to point, that is to describe a direction in space. I, J and K is used to represent unit vector pointing in the positive X, Y and Z direction. So this one is I is for X, J is for the Y, K and for the Z. Okay, for example, so we have 4I and 3J. As I mentioned before, 4I is a component X, J is component Y. So okay, so 4I and 3J, this vector we can add it using the head to tail method. So the hypotenuse is called the resultant of a vector or vector sum. Multiplication of vector. Vector A and vector B can be multiplication each other. If the final result is a scalar, so we call it a dot product. If vector A and vector B multiplication each other and the final result is a vector, we call it as a cross product. Dot products is defined as A dot B equal to AB cos theta. So as you can see here, dot product result a scalar quantity. Okay, the angle theta range from 0 to 180 degrees. If theta is 90 degrees, so A dot B equal to AB cos 90. So cos 90 is 0, so meaning that scalar product is 0. So if theta is 0 or A and B is parallel each other, so A dot B equal to AB cos 0. Okay, cos 0 is 1, so equal to AB. So the scalar product is a maximum. Example of a dot product is work done by a constant force. Cross product. Cross product A cross B is defined as a vector C that is perpendicular to both A and B with a direction given by the right hand rule. Cross product result is a vector quantity, so it's different from the dot product. So dot products result in a scalar quantity, cross product result in a vector quantity. So its magnitude is given by A cross B. Magnitude is equal to AB sin theta. The theta range from 0 to 180 degrees. So the cross product always positive value. If theta is 90 or A and B is perpendicular. So sin 90 is 1, so this one become maximum. Cross product is maximum. Okay, if theta is 0, meaning what? A and B is parallel. So since 0 is 0, so AB become cross product is 0. Okay, we still continue with the cross product. The direction of cross product A cross B is determined by two ways. One is a corkscrew method. Another one is a right hand rule. So this is an example of the cross products. One is a magnetic force on moving charge in magnetic field. So we have F equal to Q V cross B. So V is a vector, B is a vector. So V cross B, we get a result of vector. Another one is a torque. So we have a vector, R cross F, both are vector. Then we get a vector. How to use right hand rule? So we have A cross B equal to C. So we want to determine the direction of vector C. So the first one is point the forefinger to the direction of the first vector A. So forefingers point to the A. Second one is sweep the forefinger from the first vector toward the second vector B. Okay, this one is B. The thumb show the direction of the vector product C. So this one is A, B, and the C is show the direction of vector product C. Okay, consider two vector A and B. So we want to know the physical meaning of A dot B and A cross B. Okay, so first one is physical meaning A dot B. Okay, A dot B is a magnitude of B multiplied by the component of A parallel to the B. Okay, so meanwhile physical meaning A cross B is, okay, A cross B is equal to the magnitude of B multiplied by the component of A perpendicular to the B.